In this lesson, you learn about a very popular prompting technique called few-shot technique. I'll compare the few-shot technique with pre-training and fine-tuning, and then I'll discuss practices to use for applying this technique. In the last few lessons, you have learned how models can acquire temporary or non-parametric knowledge by way of instructions. In this lesson, you will learn how models can also learn from examples and how they can leverage the provided examples to generate desired responses. The examples provided to the model are referred to as the shots in the context of transformer models. What makes this example-based learning phenomena interesting is the fact that it needs far less amount of data compared to other learning phenomena. Before proceeding, let's compare the data needs for pre-training, fine-tuning, and in-context learning. For pre-training, hundreds of GB to a terabyte of data is needed. Now with newer models, we may see this number continue to grow. For fine-tuning, you need a few megabytes of labeled data for task-specific tuning. This may translate into hundreds to a few thousand examples of input and responses. For in-context learning, you just need instructions and a couple of examples. We are talking about a few tens of words to a few kilobytes of data. This learning data is provided dynamically to the model at the inference time. Not all models can learn from examples. The models that can learn from examples are referred to as few-shot learners or few-shot models. These models can learn from a few examples to carry out a novel task. The term novel task here refers to the task that the model was not explicitly trained on during the pre-training phase. Here are a few examples of such models. Cohere Command GPT-3 and Mistral AI 7 billion parameter models are just a few examples of an ever-growing list of few-shot models. In the few-shot technique, you need to provide the model with examples that it can use on the fly to learn how to carry out a task. Here is an example of a prompt that lists a set of examples to demonstrate how to assign a sentiment label to a comment. Let's go over some practices to keep in mind for using this technique. Check the model's documentation for guidance. Idea is to ensure that you are following the model's recommended best practices for few shots. There is no magic number of examples that you need to provide the model, as it all depends on the model and the task. To determine the number of examples you need for a specific task, build your examples list incrementally and test thoroughly. Ensure variety and a good mix of examples to achieve good performance. Identify edge cases and provide explicit instructions on how to handle those edge cases. As a best practice, build your prompt iteratively, test thoroughly, and continuously monitor your prompt's performance once you are in production. Though this technique is very attractive, it is not a silver bullet. There are certain scenarios and types of tasks for which few-shot technique doesn't do as well. It is a known fact that it does not work well for tasks involving mathematics, logic, or reasoning. The only way to figure out if it would work out for your task or not is to try it out. Last thing that I'll cover in this lesson are the zero-shot models. These models refer to a category of models that can effectively carry out novel tasks in the absence of examples. Anthropic Claude, OpenAI GPT-4, and Google T5 are examples of such models. It is important to highlight here that for complex tasks, even the zero-shot models may need examples to perform effectively. In this lesson, you learned about the few-shot prompting technique. This technique is an inference time technique, and it involves providing task-related examples to the model to generate effective responses. To determine if this technique will work out for your task or not, you need to try out multiple examples with a model iteratively. In the next hands-on exercise, you will develop a few short prompts. Happy learning, and I'll see you in the next class.